Welcome back. I know that it was a busy and fun design challenge time. I see a lot of activity in those classrooms, but we have our Q&A here. We have two amazing college mentors along with our presenter for the day, Kelsey Farr. They're going to introduce themselves. We have Morgan and Brianna. They're going to introduce themselves, and then it's going to be your time to shine. I know we're going to spotlight a few groups, so please have those groups ready. And Kelsey, I hear you're going to be the one sharing the slides.
Yes, I
Fantastic.
am. Okay. It was so great to see all the excitement and all of the designs that you guys came up with. It was really, the leaf blower surprised me personally, but that was definitely a pleasant surprise. So I'm excited to hear how it went. Okay. So I will be introducing your lovely college mentors today who will be fielding questions. We have Morgan and Brianna, and I will go ahead and I guess introduce myself again for you guys and give a little bit more details about my background. So I've already gone through education and current role. I really wanted to take a second to talk to you about my interests in engineering. And the first one I have on here is multidisciplinary engineering for complex problem solving. And this is a lot of big words that you might not really know what it means. But essentially, it's the concept of using multiple different types of engineering or maybe even disciplines outside of engineering to approach a complex problem. So something like, how do we make renewable energy more affordable, more efficient, more widely used, is not something that can be done with just electrical engineering, which is my background. It's something that requires input from the civil engineers, from the aerospace engineers, from mechanical engineers. It requires input on public policy. So all of those things really come together to work towards solving complex problems like the National Academy's grand challenges for engineering. So really pressing problems that are really complex, but if we all approach them and work together on them, they become a little bit easier to work towards. So that's one of my biggest passions in engineering. And then I've also done a lot of work with hybrid and electric vehicles, have some SAE published research on making hybrid buses more efficient, being able to downsize the battery in electric buses, just making them more efficient and lighter, hopefully more readily adoptable for cities. And then renewable energy and grid resilience. So those are some of my interests. Just kind of circling back to that internship experience in New Zealand, what I did for that project was I looked at some of the port infrastructure, and New Zealand in particular is really susceptible to earthquakes and tsunamis. So I was looking at if there were to be a tsunami event, what infrastructure and energy resources at those ports would be most at risk, and then trying to proactively prevent and protect those resources from any potential future damage. So that's a little bit more about my background, and I think we'll then move on to Morgan, who will be introducing herself.
All right. Hi, everyone. My name is Morgan Douglas. I am a senior in civil and environmental engineering at Virginia Tech. So civil engineering is a very broad field, but my main focuses are sustainable land development. So that is developing new neighborhoods, looking into cities, seeing how we can fix the infrastructure there. So looking at the roads, the buildings, the sidewalks, and making sure that they are both walkable and also going to be sustainable moving forward. Another interest that I have is stormwater management. So that is where the water falls on a site and where it will end up going. So making sure that it doesn't flood the roads, making sure that it doesn't flood people's houses. So that's another passion of mine. Growing up in Maryland, my neighborhoods surrounding mine, closer to the coast, they needed a lot more stormwater management than what they had in place. So that's kind of one of my big passions in engineering. And also water resources engineering is another passion of mine. So that is making sure that everybody has water. but we can go into how I got into engineering on the next slide. So back in high school, I was part of a STEM program. So I got to experience a lot of different types of engineering, math, technology, and science. And I focus in on civil engineering moving forward because that required the least amount of chemistry, which is a little funny to say that now. Looking back at it, I wanted to do more on the environmental engineering side, whereas now I'm doing sustainable land development. So that's a lot more working with the people, the client, and also more designing rather than working with the chemistry of the environments and the pollutants in place. Another thing that I did back my freshman year, I began as a general engineering student. So at Virginia Tech, we all start out as general engineering, and then our sophomore year is when we get to join the engineering of our choice. So I got to experience all different types of engineering my freshman year. And then my sophomore year, I worked in construction for an internship. So I got to experience working on a job site, working with people. That was a lot of different work that many engineers do not do on the daily basis, working with people on a job site. But that was really important to me. And it kind of helped me get my new internship. So my past internship that I did this summer, but I also joined American Society of Civil Engineers and the Steel Bridge design team. And then my junior year, I interned with Dewberry. So that's a private consulting firm. So I worked mainly in the land development side of things. And I also traveled with Steel Bridge to nationals where we placed 7th place nationally. And you guys will get to see some pictures of our bridge on the next slide. And now I'm in my senior year, which is really exciting. It's a little bit scary, but I'm staying for graduate school and I will be attending graduate school for sustainable land development. So that is actually a new program. I think it's about 5 years old. So I'll be one of the recent graduates of that program soon. And on the next slide, you can see some pictures from Steel Bridge. So on the Steel Bridge design team, we design a 1/10 scale model steel bridge. So down in the bottom left, you can see our bridge that we took to nationals last year. And we do all the structural analysis and fabrication ourselves. So we cut all the steel, we weld all the steel ourselves, and we also do all of the structural analysis. So this is a completely different field of civil engineering and part of civil engineering than what I'm planning on working in for full time. But it also gives me the experience of knowing how a structure works. And I also get to do some outreach, so talk with other students at different schools and see how they worked on their steel bridge, and also work with kids and teach them about science and engineering.
Awesome. Thanks so much, Morgan. Love that you touched on the collaboration aspect of that there at the end as well. Okay, we'll move on to Brianna, who will introduce herself.
Yeah, so good morning, everyone. I'm really happy to be with you guys here today. My name is Brianna Mahan. I am a junior studying civil engineering with a minor in Spanish at the University of Miami here in Florida. Kind of similar to Morgan, we have a lot of similar interests, which is funny. But land development, I say structural design and land development, two very, very different sides of civil engineering. But since I've only taken a handful of classes in each side of engineering, I still kind of have equal interests in them. I'm leaning more towards the land development side. But as of right now, it's still kind of both. Project management, which I like to think of it as having overseeing a project more. So making sure that all the different teams are, working on the same schedule. Everyone's working within the budget. Everyone's doing things on time, kind of having a little bit of say in each different area of a project. And then sustainability, which I'm sure you guys know and have learned a little bit from this lab, that it's a very growing field in our world today. And there's a lot of improvements that can be made within the field of sustainability. And I think it's really important that we continue to make the world more sustainable. And with Engineering Tomorrow, I have had quite a few roles and a lot of interaction with the company. So actually in high school, similar to Morgan, I was in an engineering and architecture program where I actually, during my junior year of high school, we did a bunch of the Engineering Tomorrow labs. So I've kind of been in your shoes as well, where I'm taking part in these sessions rather than leading them. But because of the impact that Engineering Tomorrow had on me and kind of figuring out what I wanted to do in life and what field of engineering was the one that suited me best, I decided to become a mentor during my freshman year. So I've been doing that for about 2.5 years now. Um, and then my first internship also was with Engineering Tomorrow as a curriculum development intern. That was a really, really fun summer. I got to work on probably like 5 different labs, both new and some old labs, improving them, creating them, working with other interns, working with other engineers, which was a really cool experience. But my favorite part of that summer was the electric vehicle and renewable energy competition. We started it, and then I actually got to go to the competition last year, which was really cool to see, basically a year's worth of work come to life, and see so many students get to enjoy the competition. And I can talk a little bit on the next slide about my college life. Most of it honestly has to do with American Society of Civil Engineers. Last year, I was the treasurer for the chapter here on campus, and this year I'm the president. So I'm very, very involved with American Society of Civil Engineers. And although sometimes it is a lot of work and there's a lot of things to do, it's such a rewarding experience. And it has given me so many connections that I would never have gotten from just sitting in a classroom, which is actually my favorite part of being in a program like this. But you can see on the slide some pictures. The one in the middle, we just recently went on a site tour of the Signature Bridge project in Miami. I see there's one school from Miami, so I'm sure you guys have seen this when you're driving like near Brickell. But that was a really cool experience. We got to go to the gala. On the bottom right is a picture of me at a conference this past or 2 weekends ago. It was called the Student Success Conference. So you can kind of get an idea of all the different things that American Society of Civil Engineers kind of provides you with, both professionally, socially, academically, whatever it may be. But I'm very involved and I really, really love it. And then I can kind of talk about the concrete canoe on the next slide. Similar to Morgan, it's like the same competition. You do both in the same weekend. We don't do the steel bridge. We focus more on the concrete canoe. But actually last year was our first year doing it. And I think 5 years since before COVID. So no one on the team had ever done it before. We just had kind of seen pictures of it and we were like, oh, we should try. So it was definitely very challenging. It came with a lot of issues, from budgeting to acquiring a space large enough to build a 20-foot long canoe, to not having enough people at times because the civil engineering department here in Miami is very small. So it was definitely a learning curve. But honestly, I think even though we didn't do well, number one, we came in very last place and our canoe looks a little wonky if you couldn't tell from the picture. But I think the most rewarding part of that project was getting to see something from start to finish, from planning it, from building the from building the tent that we were in, to building the table that the canoe was on, to doing the concrete mix design, to casting it, to sanding it, everything. We did every single part of that project, and seeing that from start to finish was honestly something that I could never have imagined. And then the relationships I formed with the people in the picture on the top left will last me a lifetime. And we are all still friends to this day. Even though we've had a whole nother set of issues with the canoe this year, we still talk to each other all the time. A lot of them are older than me, so it's a really good resource to have when it comes to, class selection, like what professors do you like, what professors don't you like, how did you feel about this class, did you like it, should I take it? So I feel like those 2 slides just kind of give you an idea of mostly what I'm involved in here on campus. I also had an internship last summer with a company called Langen Engineering. I also was a site civil intern similar to Morgan, so doing a lot of land development and plans and working with AutoCAD and all of that. But yeah, that's just a little bit about me.
Awesome. Thank you so much, Brianna. And I love there that you touched on the fact that even though it might not have been the best concrete canoe, or it actually might have been the worst, you still had a good time and had a lot of learning that came out of it. Because if there's anything that I think any engineer will tell you, it's that there's going to be something that doesn't work out how you plan. And it's really what you take away from it and what you learn from it that makes the difference there. So yeah, great points from both of you guys. Thanks for that. Everyone, you can feel free to put some questions in the chat for our college mentors. Any questions that you have about deciding on an engineering major, choosing which college to go to, any questions you have about the lab, feel free to put some of those questions in chat.
And then I'm going to just hop in and say, if anybody's ready to share, please raise your hand or so we can spotlight your group. I know we had a lot in the breakout room that were ready to share. Oh, I see one. I'm going to spotlight you. I think that's Joanna Cottle at Columbia Heights in Washington, D.C. Joanna, I spotlighted you. Can you guys unmute so we can hear you?
Hey, oh, yeah. Yes.
Nope, you're
unmute.
good.
Oh,
You're
am
good.
I
We can hear you now. Yes.
All right, great. Well, we are really excited because we had lots of really creative and fun designs here, and I have a few students who really want to show off what they've done. So I'm going to ask them to come up right now, and they're going to show you their designs.
Fantastic.
What do you do? Yes, Mrs. Brown, come on. This is a beautiful one. Let's go. It doesn't have to be finished already. Just tell them your first name. All right. Okay.
Let's go. Come on, let's go.
Come. Our group should come up with us, right?
I don't even know what we did, but let's
You're
go.
on camera, so let's go. Here we go.
Oh my God.
This is our.
There you go. Just say a little bit about what you came up with.
What do we say on this?
It's a dog.
Representing DC, don't embarrass them.
My name is Odemar Del Cruz. I'm a senior, and this is my project.
Okay, come on.
Nice. I like that you included the tail there as well. That's a nice touch.
All right, this is mine right here.
Back up.
Hold on.
Talk a little bit about what you did.
I just wanted to make it like a house.
Where's your solar? Show the solar.
Right here, in the back.
And we had very limited materials, and he was able to come up with all of this in just a short amount of time.
Got the stairs. It's in the detail. You got the stairs.
Oh yeah, and you have a little flap for the door there too. I like how you have the solar panel on one side and the wind on another. That's a nice touch.
Oh,
Yeah,
this
I
is
really
my
like these
prototype.
designs.
I did a regular regular design with double solar panels. I put most of the wiring inside. I connected the what is this called?
Wind turbine.
The wind turbine, and just in case you need to check with the lights, I can just disconnect it from right here and it'll light up.
Check the circuit.
Yeah, I already checked it and it works. That's pretty much
I
it.
like that the wires are hidden on the inside. That really helps out the aesthetic.
Yeah, and we're hoping to go outside for a little bit and see. It's a pretty sunny day here in DC, so we're going to go see if we can get those dual solar panels powered up to run the fan on the top. So they're trying to run the fan off of the solar panels. So that's
Awesome.
That's one.
Did anyone raise your hand if you guys had any difficulties with wiring your solar panels or your wind turbine? And if someone wants to share, how did you overcome that problem? Was it trial and error? Did you take inspiration from other groups? Did you ask questions? Kind of tell us about that.
Oh, you're a little nervous. We
Okay,
did have some
no worries.
we did have some struggles with wiring, but in particular, I think something we found was hooking up the generator to get it to light up the LEDs. That was it was hard to figure out which way to blow. We had to use our own wind power inside the classroom here to get things to work. So that was a bit of a challenge for us, and but it's been such a fun experience. This has been a fantastic classroom. So thank you to everybody. Thank you for your great presentations, and we'll turn it back to you.
Thanks for sharing.
Yeah, thanks so much, Joanna. Love to see all the innovation happening in your classroom over there.
Well, I want to say that was fantastic to see Joanna, an ET staff engineer, live in a classroom is fantastic. And I think I had another group that said they were ready to share. but I don't see anybody at the camera. Oh, are we ready, Mr. Jerry Dawes? Yes? Oh, you're on mute. I cannot hear you. Are we ready? There we go.
And this is the leaf blower group, right?
So hello, everyone. Jerry Dawes. I'm at the Academy in Uniondale, Long Island. So, all right, so let's go. If you could just introduce yourself, give your name.
Hello, my name is Destiny Cunningham from the Academy Charter School, and me and my team made this build. It's functional. In order for us to have it together, we glued down the almost rotor things. And for the solar panel, we glued it to the roof of the house.
You have any questions for us?
No, very nice. I love how you have the fan blades up higher than the house, because that's one of the design considerations is there's more wind up higher. So you've already incorporated that. Great work. It looks awesome.
Another really good thing I see.
All right, thank you. Round of applause, please. And we have another student ready to present.
Okay. Okay, so my name's Tamara. It's basically the same thing. I use the solar panels and I put it to top, and I use those right here. And yeah, it's just like a process.
Another round of applause. One more student, come on up. Come on. Yeah, introduce yourself. You could just introduce yourself, give your name.
What's up? It's Shamel Belton. We have my windmill that moves whenever wind. That's how it turns on, use wind power. And the, what's it called again?
Solar panel.
A solar panel that use solar energy from lights to light up right here. So yeah, this is what I made.
So Shamel, we're gonna give a demo because we were able to get a leaf blower and we put some really heavy wind on this to show how it works. So Shamel, stand there right there for a quick moment.
Got it.
Yeah, this is the real test to see if it stands up to the wind.
So after 3, we're gonna give it a shot. So we lit up the LED with a good leaf blower.
Wow.
Yes.
That's awesome.
All right, thank you very much,
Wonderful.
Shamel.
That's
Very creative.
That's wind energy. All
Thank
right,
you, guys.
thank you very much, everyone.
Yeah, thank you.
Yeah, thank you, Jerry. Thank you, the Academy Charter School.
We have, sorry, the chat has been going crazy. I have Lumpkin County High School who turned on their camera and they're ready. Can you guys unmute so I can spotlight you?
We're ready.
Oh, I'm looking at the wrong.
Let me just pick it up. Wait, hang on.
One thing I want to say that I love seeing from pretty much all the groups is the angle that you're putting the solar panel. And I think this might have been in your intro presentation earlier, but that angle is really important so you can maximize the amount of sunlight. If you think about on a real house and if it's on your roof, that's a triangle. It's going to be at an angle all hours of the day. So when the sun is moving, you can get the maximum amount of power to store up and then use for the future. So I really love that you guys are taking that into account and making this more of a real world application.
Yeah, to piggyback off of that, I also like that the wind turbines are also pretty high, just kind of mimicking real life in this lab as well.
All right. Hi from Lumpkin County. Hello. All right. What you got?
I see the light.
Wow. Yeah, I see that light. That's very bright.
Mm-hmm. That's a pretty big house too. I like that. Go big or go home.
Great job, guys. Anybody else? Gentlemen, did y'all want to show yours? Oh, come on, it's awesome. Bring it up. Bring it up. Bring it up. So, yeah, come on. Come on, right here. It's like you're targeting people now. All right, so I'll let these gentlemen tell you what all they put together. We got some future wannabe engineers.
All right, so we made this basically a silo. So instead of like a house, it's more of like a giant silo with a bunch of power in it. And if you blow on these two, Landon, they get different lights inside. You can see the red and yellow there, and then the bottom one. The bottom one.
That's awesome.
Oh, I like the creativity put into this one.
Lights in there. And then on the back here.
And then if you flip it, we have lights on the back too.
Oh my gosh.
Yeah, you
That's a lot.
guys made a
I like it.
complicated design. How'd you have time for all of that?
And they have a helicopter pad on top.
Yeah.
I love
Very
it.
creative.
Yeah,
Thanks for
great
sharing.
job, guys.
Margaret, Sophia. No? All right.
Fantastic.
Well, thank you for this opportunity. The kids have really said that they have loved doing this, so thank y'all.
Yes, thank you, Lumpkin County. Thanks for sharing. Love to see it.
All right, I have challenge prep was up next. Is challenge prep ready?
Yes, we are. Why are you talking? It was tall. No, him. Look at my stuff. There we go. Yay. Okay, go ahead.
Hi. So this is our building we made. Our wind
Step back.
turbine.
Well, step backwards. There you go, sweetheart.
Our wind turbine is like in the back on top of our house, and it's lighting up the red LED in here. And our solar panel is on this side, and it's lighting up our blue LED here.
Cool. Yay.
I love the aesthetics of this one. It looks good. The design and the extra colors. I'm a big aesthetics girl. So
Yeah, it looks great.
Yeah.
Did you have any problems when you were designing it, or what would you do differently if you could do like remake this design?
What would you do differently?
Well, what was the problem you had with the roof?
The roof.
Oh, yeah, our roof is just a tad bit uneven. What I would do differently is make the flat part of our roof taller so we could just put our wind turbine like on the edge.
All right, thanks for sharing.
Great idea.
Thank you.
thank you.
Great job, challenge prep. So I had All Hallows. They said they were ready. Are we ready at All Hallows?
Yes, we're ready.
All right, we can hear you guys. Let's see what you guys made today.
Oh. They're coming, they're coming. Let's figure out.
I figured a lean. All right, we gotta go down. Yeah. All right, so you unmuted?
Guys in the back. All right, go.
So we went for we couldn't use a solar panel because it kind of broke. So we went for a wind turbine. We got thing up here, spin that, and then the light at the bottom to turn it on. So you spin that, and then that will turn on. And all the innards are inside, so it's all built there and then decorated it. Yeah. Decoration.
That looks awesome. I like that you guys were working with what you have. Like you said, the solar panel broke, so you just improved upon the wind turbine design, and it looks great.
We got a couple other ones with ones that work though, so I'm gonna do 2 more quick. All right, come on, Daniel.
Yeah.
Yeah. So we went with something like minimalistic. We went just a basic design, but we used solar panels, and then it actually worked for a little bit, but we don't have much sun, so yeah.
All right.
Are we unmuted?
No, they can hear
Yeah.
you.
Yeah, we can hear you.
Yeah, that's great. Yeah, so and like I had mentioned in the intro session too, sometimes it is difficult to get the solar panels to work inside and even like through the window, especially in the winter time as we're getting into that time of year. So yeah, glad to see that you were making do with what you were able to get work. It looks great.
All right, last two come up together and then we'll be done. So they can see it.
Hello there. We are from John F. Kennedy High School. My students are ready to present their model.
You are going to be next. Give us 1 second. All Hallows has one last group, but thank you guys.
One last group. So we were basically inspired by a wind turbine. We got a cone right here. We have the solar panel here. You know, we just decided that we were going to just make like out of scraps. We just, you know, made everything. It took 5 minutes. You know, we decided to rebuild from scratch. You know, with our minds. Thanks.
Well, one part of engineering is to be innovative while also building fast, at least with project management. So that's really cool that you were able to make both the wind turbine and also include the solar panel on top very quickly.
Yeah. Had a great time. Thank you. Yeah.
Great job, guys.
Fantastic. Thank you, All Hallows. All right, I'm going to John F. Kennedy. I see you guys are ready now. Let's have spotlight you and you guys can unmute. We can hear about your design.
Okay, this is our design. We'll put solar panels later, but this is our windmill. We made it tall. And yeah.
Okay, let's see if we can test it out right now. Can you move it this way? Yeah, face it this way. Okay. Too far. Oh. It works, but it's too far right now.
Yeah, I saw it spinning, don't worry. Yeah, there it goes.
Yeah.
That's awesome. What made you guys, it looks like you separated the two different wires up there. What made you decide to do that?
I don't know. We just wanted to.
Yeah, it just seemed like the right thing to do. Well, it's interesting because, you know, not a lot of other groups did that, but that is another thing to keep in mind in engineering is things like cable management and keeping things neat. That is something to consider as well. So it's interesting that you kind of just intuitively decided to design it that way. Great job.
Thank you.
Great job, guys.
Thanks for sharing.
Do you have another group, John F. Kennedy, or no? I think
I do have my other class made one. I can show you their work right here. They made this one that works beautifully. They're
oh
not
my
here.
gosh.
That's amazing.
Time, so they're gonna be here later, but it works and it lights up and there's a green light that shows up. It's a beautiful project. So yeah, they're working on it right now. We just started yesterday and it's morning time here. It's our first period, so yeah.
Yeah, that's amazing. It looks like that one's even on risers. It looks really well designed, like professional almost. Great job, guys.
Thank you.
fantastic. Thank you for sharing, John F. Kennedy. We appreciate that.
Thank you.
All right. I don't think there's another. Oh, wait. I see some movement, but I don't think there's another group that's ready just yet. But I see we have some questions in the chat. Brianna, if you want to hop in there.
Yeah, so the first question from Charles Herbert Flowers High School in Maryland is, where does the power coefficient in the equations come from, and how is it used on my utility bill? That's a good question. Maybe Kelsey, if you...
Yeah. So I was actually looking into this because it is a really good question and I wanted to find out as well. I did not know originally, but I looked it up. So the coefficient of power that's used in that equation is more relevant to the direct process that is ongoing. So it's the efficiency of the wind turbine that's being factored into that, which will impact your power bill ultimately by the time the electricity gets to you, but it's not necessarily something that you're like, for example, is applied to your power bill every month. It's more of a longer term impact, more indirect, I would say. So yes, it impacts it, but maybe not as much as you might have been thinking. Yeah, great question. Thank you for that. So then it looks like another question in here. My students are working on making windmills with cardboard and CDs. What are some design tips they should consider to get maximum energy output? Morgan, Brianna, any ideas on that one from what you've seen?
Yeah, I think just making it as sturdy as possible, and also trying to make it tall. So just using the cardboard to go up and maybe using a CD as like a holding location to hold the wind turbine in place. That might be beneficial. But I'm not sure if Brianna also has any tips or tricks. I think that just using the cardboard and making it as structurally efficient, that's a really good one.
Yeah, that was going to be the same thing that I said. I think a really important part of this lab is stability, and making sure that when you do use the wind power, it's not just going to tip over, because then you're not going to get any output at all, if that makes sense. And then also with the CDs, I think you can get really creative. I actually have never seen a school use CDs. So yeah, just kind of think out of the box, play around, mess around, like Kelsey was saying. It's a lot of trial and error in engineering. So yeah, just go crazy with it.
And I saw Porter High School typed in the chat that they would like to share. I see their cameras on, but I don't see a group at the camera. Porter High School, are you ready to share or no? Oh, I guess not. So sorry, guys. If you are ready, Porter, just let us know, give us a wave. And if not, we're going to keep going. I think one question that is always on teachers' minds is, what is the best classes in high school for students to take to prepare them for engineering in college?
I can start out with this one. Well, I can kind of talk about my own personal experience, and I feel like I had a really good transition from high school to college. So I took a lot of AP classes my senior year. My junior year, I think I only took, what did I take? I think I took AP Spanish junior year, which doesn't really help me with engineering. But senior year, I took AP Calculus BC, which was a very difficult class. I can't say I did well in it, but it taught me all of the topics and stuff that I then had to, when I got to college and I was taking Calculus 1 again, it was more like a review rather than learning anything new, which I think really helped with my transition, because it's like I'm not taking a completely new class. I can kind of, not to say that I didn't focus on the classwork, but it's just, there's a lot that goes into transitioning from high school to college. All these new people. I moved from New York to Miami, which was a really big change for me. I didn't really know anyone who's going to my school. I'm an only child, so I had, it was really hard for me to leave my parents. So I think kind of having that as like a more of a refresher was really helpful for me. And then same thing with physics. I took AP Physics C my senior year. And I did well on that one, but the credits didn't transfer. So again, I had to start back at Physics 1 when I got to college. So again, I had another class that was more of like a refresher rather than learning something completely new. So I think if you can kind of try to take those advanced level courses or AP courses, or even I know some students who, if you can do like like what is it called? Like a dual degree, where like you're taking some college credits while you're still in high school, just to kind of get yourself prepared for that. Not only the level of coursework, but like the just the topics in general. I think that would be helpful. And if you do really well on the exam, that's perfect. Then you get to skip that class once you get to high school. I mean, once you get to college. And if you don't do great on the exam, that's okay. Like I said, you already have gone through the year of learning the same knowledge. So it's really just going to be a refresher and kind of help you with that transition, not having to worry so much about like, oh, this is a completely new class. I'm overwhelmed with moving in, with roommates, with finding new friends, with joining clubs. There's a lot of stuff that goes into moving into college. So I would say that is what helped me the best and best prepared me. I don't know, Morgan, if you have a different experience.
Yeah, I think that definitely, at least with coursework, taking APs helped me the most to prepare. But honestly, I feel like putting yourself in classes that you feel slightly uncomfortable with, that will best prepare you to go into college, because then you have to force yourself to study. You have to kind of get used to being in a class that is difficult. So I wish that I took AP chemistry. As I mentioned earlier in this session, I do not really like chemistry and I didn't take that, but instead I took AP biology, and putting myself in that situation, it taught me how to study for something that I'm not particularly interested in, and that helped me move forward into college, because your first 2 years, if you go into engineering, will most likely be the general education courses. So you will have to take courses that are not related to your degree. And that molds you, and it kind of changes your perspective on how to study and how to go about your coursework. And then it'll be easier once you get into courses that you enjoy.
Also, I just want to add, I had this thought when I was in high school. I was like, okay, I'm going into engineering. I'm never going to have to take an English class ever again. Like writing, I'm done with essays. That's not the case, unfortunately. I'm a very weak writer. It's not my thing. I don't like it. But just don't go into college with that mindset of, this is my major. I don't have to do anything else other than what is related to that major. Like Morgan was saying, it's most likely, regardless of what you go into, going to be general education classes for your first or maybe even second year. So just kind of having that mindset, like, okay, I'm not quite done with the things that I don't particularly like to do yet. You still kind of have to get through those couple classes of, things that aren't necessarily your interest before you kind of get into the things that like you want to pursue and the things that are related to what you're studying.
Morgan and Brianna, thank you so much for your insights here. It's really been great to hear from you guys. I'm sure that all the high schoolers have really benefited from hearing your insights about college and some of your insights on the lab material as well. So really thank you for that. And thank you also to all of the teachers and especially all of the students and the engineers who are also live in our classrooms, Joanna and Jerry. Thank you to all of you guys. I've been really loving to see all the innovation and designs that are coming out of this. So we're going to wrap up there and transition now into our keynote speakers, Dr. Frank Fish and Jay Iyengar, who are both here now. First, so it'll be 2 separate sessions here. Each keynote speaker will talk, and then we'll have time for some questions for both of them at the end. So it looks like Porter High School is saying that they are ready now. Do we have time for them to present, or should we wait?
I think Dr. Frank Fish is ready, so I think we're
Okay.
going to hop right to our keynote just to stay on schedule. Sorry, Porter High School.
Yeah, sorry, Porter. It looks like you guys have a great design, though. Maybe we can share later if there's time. Okay, so without further ado, I will introduce Dr. Frank Fish, who is a professor of biology at Westchester University of Pennsylvania, and there he is the director of the Liquid Life Laboratory. So his team works with biomimetic systems, so things that will mimic ocean life, land life, just animal life in general, plants. So looking at some of those things, and he's also the innovator behind tubercle technology for wind turbines. And I will hand it over to him to explain a little bit more about what he does and what he has learned.
Okay, thank you very much. It's very nice being here, and I've listened to some of the comments and such, and saw some of the windmills. I think that's really great. I'm going to take you in a new direction. So if I can share my screen here. Yes, I can. And then go to my presentation mode, comma. There we go. Okay, so I want to talk about how we can take what we learn from animals and create technologies that can help for renewable energy as well as other things too. As was said, I'm a professor of biology at Westchester University. I have some background in engineering and I work with engineers all the time. Just to give an idea, I work typically with large animals, okay, which is different than a number of biologists who may work on things that you need a microscope. I work on things that microscope would sort of not fit in well at all. And because I have a knowledge, particularly of how animals move, their locomotion and such, and how they're designed to move efficiently, I've been called on by engineers to work on their projects. So some of these include the creation of a robotic sea lion, which you can see there on the left-hand side of the screen, and then also a robotic sea turtle slash tortoise, that is where it can actually swim using flippers, and then those flippers can morph into legs for walking on land, and then also a robotic manta ray. Based upon this, we've developed a swimming ray. These are what are called autonomous underwater vehicles. And so in understanding the animals, we can make better aquatic robots. But what I want to talk to you today about is sort of this other aspect of biomimetics. And what biomimetics attempts to do is to take what we learn from biology and then incorporate it into engineered systems to either do better or just improve those systems. The biology can often work as a benchmark in which the engineers try and mimic or get close to the performance. So whether it's bullet trains or Velcro or shark skin, or a lot of what I do is to take what we learn from dolphins and whales and replace things like screw propellers. Now, you never know what's going to be important. I heard some students saying, okay, when they got to college, they just wanted to concentrate on their particular discipline and hopefully would never have to write another essay again. Well, that's not what happens in college. You will write essays. And I would say learning how to write, learning how to speak is important, because as you make discoveries, you have to communicate those things. And sometimes discoveries come from odd places. James Burke did a program called Connections about how technology has developed over time. And he referred to serendipity. Serendipity is sort of the surprising sort of innovations coming out from just another source altogether. And for me, it happened because I happened to look at a little sculpture in a store and thought that the humpback whale sculpture that we have shown here got it wrong, that these bumps were on the wrong side of the flipper and that the artist had made a mistake. In actuality, that's not the case. The humpback whale has these enormously long flippers, about 1/3 the body length, and they have those bumps on the leading edge. And what they do with let me go back. Here we go. What they do with these large flippers and the bumps, as we'll discuss, is that they can maneuver quite tightly to create what we call bubble nets and trap prey such as fish or krill, and then concentrate them so that they can come up and feed upon them. Now, if we look at a flipper of a humpback whale, it's essentially just a long arm and hand. Okay, the bones are all there. They're missing a thumb, but essentially they're the same bones. And the interesting thing is that they have this wing-like appearance. And in fact, if you make a cut through it, and sorry if you've just eaten your lunch, but there's a cut through of a flipper, and you can see it has that nice fusiform design, sort of like an airplane foil shape, or for that matter, a windmill. And curiously, the bumps which are on the flipper are fairly regular in their placement. And so that sort of indicates to me at the time that maybe there was something hydrodynamic going on. The bumps weren't simply just where the knuckles occurred between the bones of the hand. And so working with an engineer using what's called computational fluid dynamics, using a panel method simulation, we then compared the humpback whale flipper versus a regular wing section. And we had it at an angle of 10 degrees, angle of attack. And you're all familiar with that. If you stick your hand out a car window, your hand, if it's sort of level with the ground, gets pushed back, that's due to drag. If you cant your hand at a slight angle, you feel an upward push as well as the backward push, and that's the lift. And the angle is the angle of attack. And what we found was that having those bumps, or what we call tubercles, in front of the wing actually led to compartmentalizing flow and reduced the drag on it, as well as increasing the lift, and also delayed what we call stall, which is a loss of lift. Okay. So working with another engineer, Lawrence Howell at Duke University, we fabricated a flipper, more perfect than perfect flipper, took it to the Naval Academy, and then put it in their wind tunnel, compared it to a baseline model without the tubercles. And what you see here is, for various angles of attack, we have the lift coefficient. And what you can see is that for our wing with the tubercles, that we don't really change that much in terms of the pattern of lift, but we get a little more lift, and notice that we don't stall. That is, the baseline, you can see, falls off rather dramatically. That's a stall. But here with the tubercles, you don't get that stall. It comes much later. Oops. Shoot. So if we look at the drag, okay, we find that having the tubercles, there's no penalty for that in terms of the drag. And in fact, because the wing didn't stall, okay, we actually had lower drag at higher angles of attack. Now, how does this all happen? Well, if we look at a regular wing, as we increase the angle, we start to see flow separation. That is, the flow over the wing starts to move away from the wing and become very turbulent. And if that flow separation occurs more anteriorly on the wing, eventually that wing's going to stall. But what happens with the tubercled wing is that we get these paired vortices coming off the wing as the flow is deflected by the tubercles. Flow immediately over the tubercles is energized so that we don't get that separation. We don't get that stalling effect because of the position of those vortices that are created. Vortices are just sort of little cyclones, okay? And so we can see in these here that we get this sort of rotating bit of flow, but over the tubercle itself, the flow goes straight back, doesn't stall. This is like, you can think of it like a baseball pitching machine, where you have two counter-rotating wheels and the ball gets squeezed between them and then accelerated out. That's what's actually happening. And because of that, we're not getting any sort of stall, and we get that increase in lift. Now, not only that, but when we look at the wings and we look at how they're setting up flow, we have a wing with tubercles on the left, a wing without the tubercles on the right. And the one on the right produces what we call a wingtip vortex. And you can see that in the lower part there. And you can see that as contrails coming off of planes. If you look at the sky when an airplane's going by and you see the white coming off the wings. That tip vortex leads to a lot of things, a lot of loss of energy. But with the tubercles, we don't see that develop as much. And in fact, what's happening is the flow goes sort of straight back, which makes a more efficient wing compared to a wing without the tubercles, where more of the air is sucked along the wing and creates that wingtip vortex in which we lose energy. And so the tubercles act as sort of aerodynamic fences. They make the flow more two-dimensional, which makes it more efficient. Okay, it reduces that tip vortex, reduces the drag, and also reduces noise. When you hear a fan, the noise is coming from those tip vortices. So people have put this into action to be more efficient. So there's a company in Canada that had used the tubercles on its fans. The fans were used in arenas and barns, and it was a win-win situation, okay? The end user had a 25% savings in electrical energy to run those fans and move the air around, such as in this cattle barn, okay? It reduced their heating costs, and it was quieter. For the company, they won out because their previous fans needed 10 blades to move the same amount of air. Oops. Now, we can apply these tubercles then to computer fans, okay, to cool computers, which use a lot of energy, also takes more energy by having inefficient fans. And so here's a way we can improve the fans and that way make computing more efficient overall. But then here's the thing in terms of renewable energy. We actually put tubercles on a windmill and tested it up in Canada with a company called Whale Power. And what we found in the lower graph there, you can see that compared to a standard blade, which is in red, the tubercle blade was able to produce more electrical power for that windmill until it reached its maximum. So we could get about a 20% increase in power generated from the wind turbines with the tubercle blades. And this also works not only for windmills, but also for tidal current turbines also, that is underwater. Both of them are ways that we can increase the effectiveness of those sort of generating structures. Of course, the question becomes, how do we then utilize this? That was a small windmill that the data was on. How do we do this on a large windmill? We're not going to take windmills and we're going to take their turbines off, their blades off, because they're just immense in size, and we're actually predicting that they're going to get even bigger. So how do we modify things and keep the costs low so that we can make the windmills more efficient and at the same time not bear a huge cost for the windmill owner? Well, the way we do that is by capping the leading edge of the windmill blades with the tubercles, just like sort of capping a tooth, and then blend those tubercles in. And we can create then, even with these massive 2, 3, and beyond megawatt generating windmills, we can create a more efficient wind turbine. So it is possible then that we can learn from the particular design of animals from nature, okay, ways of improving systems, and we can blend those in to our best technologies. So thank you, and yes, I don't know how we want to do this, but
yeah, thank you so much, Dr. Fish. That is wonderful. Honestly, something that really blows my mind personally, so thank you so much for sharing that. We'll move on now to Jay Iyengar, who is our next and certainly not least keynote speaker here. Jay has over 30 years of experience in automotive, aerospace, and advanced water technology fields, and she is currently the Executive Vice President and Chief Technology and Strategic Sourcing Officer at Oshkosh. So please help me to welcome Jay.
No, thank you. Can you hear me okay, Kelsey?
Yes, you're all
okay.
good.
Right. Dr. Fish, thank you. That was a great, it was very interesting just listening to biomimicry, taking from nature and creating technologies that make a lot of sense. But hopefully I'm seeing a lot of schools, and hopefully the schools can hear me. As Kelsey mentioned, I'm gonna come from a business perspective. I've after my education, after my engineering degree, I've been working for the industry. So I'm going to come from a business perspective. And you've been talking a lot about, I think, stationary power. I see the projects you're working on is all about stationary power. I'm going to come from the lens of mobile power, right? Coming from automotive, coming from the vehicle side. As you probably know, it's the largest consumer of overall energy in the world is also automobiles, right? One of the largest energy consumption. So what do we do? Like, how does the industry take a look at, approach that from a renewable perspective? And also, how do you stay in business? It has to be economically viable. It has to be something the customers are going to adopt. I'll just talk through what those challenges are. I'm going to see if I can share my screen, and hopefully that works. Can you see my screen?
It looks like it. Yes. Yep, we can.
Okay, got it. Let me go through share my full screen. Okay. Okay.
We see the presenter view.
Okay, got it. How about now?
Yep, perfect.
Okay. So, if you just look at my job title, part of my job is also to select the right technologies. And I'll tell you what that means is the technology has to solve a problem for the customer. The technology has to be practical, that is scalable, as well as that is something that the company can sustain, sustain business, right? It's always easy to take a very expensive technology, and if the company cannot stay in business, if it's too expensive, the customers cannot afford it. That makes it very challenging. So the challenging part of my role is to select the right technology and make sure that it is sustainable. From multiple lenses, we are looking for sustainable environmental sustainability. We're looking for technology that addresses the customer issues. And Dr. Fish mentioned, really having more efficiency. Anything you can do to increase efficiency is an overall, the right thing to do, right? There is something immoral about waste. Anything you could do to reduce the waste is a key part of it. So as you're all in, high school students, hopefully going into engineering careers, as you think about, what's the end game and where do you end up in the industry, whether you go into academics or go into the industry, at the end of the day, things have to be sustainable from the sense it has to be affordable, and it needs to scale up on its own. I'll give you a little bit of flavor for that. I work for a company called Oshkosh Corporation, and do not mistake that with the Oshkosh Bigosh. It's not a clothing company. We are a vehicle technology company. I'll give you an introduction of who the company is a little bit, so that you understand the context of what I'm referring to. Oshkosh is an industrial technology company. We do all those vehicles that you see there, and things that we do are purpose-built vehicles. We don't do automotive, your passenger vehicles, but any kind of purpose-built vehicle. A good example that you see, the red vehicle in the front is a fire truck, right? And the one that's next to it is also an airport rescue fire truck. And then you see a white truck on the left that is actually your garbage collection vehicle. All the way on the left is a military vehicle. On the right, you see something called JLG. That's an access aerial lift platform where, and the one next to it is a postal vehicle. So what we do is, if you think of, we use the tagline, we serve everyday heroes. Those who have very, very difficult jobs, people that work at height, construction workers, your firefighters, people that collect your garbage every week, right? That's the 7th most dangerous job in the world, in the country. And the soldiers that go, and your mail delivery. So if we think of the common theme, we do purpose design vehicles that serve our everyday heroes, right? And the key part of this is also, and obviously, just like anything else, we make sure it's safe, it's productive, sustainable, reliable solutions. Technology is a very, very key part of it. And I'll talk about why renewables come into play here, and I'll give you examples of that. So as a company, we also focus on sustainability, our own carbon footprint of how we manufacture, as well as our products, right? Our products get used on a daily basis. What emissions does that generate? What kind of fuels does it use? All becomes a part of our sustainability framework as we think about it. So if you get into, I kind of touched on these product portfolios. You see fire and emergency vehicles, defense vehicles, construction, environmental, last mile delivery. Either, as an example, the next, the USPS is going through an upgrade of all of their mail delivery vehicles. Every mail delivery vehicles coming, starting next year will all be Oshkosh vehicles. You see the picture there, and I'll touch on what the technology there and how that's sustainable, how that is, renewables are a part of it. So as a technology themes, we talk about electrification is a key part of it, going all the way from hybrids to full EV vehicles, which are one of the players of renewables, right? Talk about autonomous, which becomes more and more efficient. You consume less fuel, you can optimize the vehicle operations. That's one way you reduce the fuel consumption. That's also part of our play. Connected products that you can actually do fleet management on your app, and AI is a key part of it. So all the technology themes apply across the platforms I'm referring to, and they work for, generating that technology-driven value proposition we're looking for. It's kind of interesting that I'm sure many of you fly a lot. Anytime you go into the airport, you see all of the airport ground support equipment, including the bridges that you walk on, are all completely Oshkosh vehicles. So a very broad portfolio of technology vehicles, and all the technologies I'm referring to apply across the board. So on the technology themes, I did touch on these things. Again, innovation for the sake of an innovation doesn't do anything. It has to be very targeted. It has to be customer centric. It has to solve a problem. That's the only way it can scale up, and that's the only way it can everything that we do has to show a value proposition. An example of a fan blade you referred to is, there's got to be a calculation on the energy savings, and what does that mean in terms of our consumption? What does it mean in terms of business case? So everything has to have a total cost of ownership and a business case as we talk about. I'm going to focus the discussion on electrification because we're talking more about renewables here at the moment. So I've got a couple of slides on kind of, the idea is that we can, gasoline and diesel fuels are probably not renewable at the moment. Renewable vehicles, you talk about solar, you talk about electrification, but there is a lot of progress made in these fuels, as well as the engines and engine technology that consume these fuels. I wanted to give you the landscape of it before I go into electrification. Clearly, you can probably see the slides, biofuels, using ethanol and biodiesel, more environmentally friendly. Compressed natural gas and liquefied petroleum gas are going to be, much favorable in terms of emissions perspective. But know that every choice that you make, there is trade-offs. It isn't just one size fits all. You have to think about the infrastructure, how these things get distributed, and where these things apply. What does the customer use the vehicle for? A lot of things have to go into account when you make a technology choice. So these are conventional, and then let's come into some of the advanced gasoline and diesel formulations. There's synthetic fuels and renewable diesels, right? Made with sources like waste oils and fats. They're trying to create fuels out of it, and everything has, again, pros and cons as you think about which applications. But overall, electric vehicles, I'm sure Tesla sort of started this revolution of on the passenger car side, and You do see, pretty much every auto manufacturer going into full electric vehicles. Even in the spaces that I talked about, all those heavy duty vehicles that I mentioned, electrification has a significant value proposition. Now I'm going to give you a few examples of it. It isn't just about zero tailpipe emissions, and it's also about these vehicles are work vehicles. They're all there to do a work. There's a lot of hydraulics that are in these vehicles. Anything to replace the hydraulics with electrification. There's a significant customer benefit in terms of environmental benefits, controllability, the speed in which they can do their work. So there's a tremendous amount of benefits there. And the battery technology over time is getting more and more affordable. That the value proposition of total cost of ownership, value proposition of these technologies are beginning to outweigh the cost. So we are seeing a lot of interest in electrification, and there's many products going into production. You're going to see more and more of that in the near future. Clearly, you see hydrogen fuel cells are part of renewables as well, where just using generating hydrogen, generating electricity by combining hydrogen and oxygen. The only byproduct is water vapor, so there's no other environmental issues. And then obviously using that as another form of electrification versus battery electric. Again, challenges, we have infrastructure issues, there is life concerns of these fuel cells. A lot has to be thought about before a technology becomes scalable. So I am going to talk through, as I mentioned, everything that you do has to thought through what's in it for the customer, what's in it for the user. So this slide shows a simple example of a few benefits of electrification, right? Access is all of the equipment that works at height. If you go to a construction site, you see those boom lifts. People stand on the boom lifts or scissor lifts where they're working at height. All of the electric, that's the first one there. You see that there's a noise benefits. You're not going to have hydraulic leaks. Let's say you're trying to fix a ceiling inside a hospital within a clean room. You don't risk any hydraulic leaks because it's fully electric. There's benefits, there's better controllability, oil-free, better maintenance. You see that part. On the defense vehicles, you see there, defense vehicles, they do carry a lot of power. They would like to have export power capability. The generators on these vehicles to generate power when soldiers out on the field. All of the export power capability can be exponentially increased with electrification or hybrid technologies. Better maneuverability. They can turn off the vehicle, stay comfortable in the vehicle, do a silent watch. It actually supports their mission. So there's benefits there. Fire and emergency, the fire trucks, fire trucks actually start and run with diesel emissions inside a firehouse. There's emissions concerns there. Fire trucks driving through a long tunnel will generate emissions. There's noise concerns and being able to control the pumps that are on these fire trucks. These fire trucks are, pretty, they aren't just driving vehicles. There's a lot of things that the trucks do to really support its mission from that sense. So fire and emergency. In a fire emergency, we've got vehicles up there. I'll show you some pictures of it. Refuse collection. This is your weekly garbage truck that comes early in the morning to your household every week and collects garbage. All of those will be electrified going forward in the next years or so. And again, because it's faster, better operational efficiency, environmental benefits, and zero emissions. And then last but not least is the last mile delivery. That's a USPS, United States Postal Service delivery truck. This will be the largest electric truck fleet in the United States. And it is launching now. So you'll see more and more of these next year. Again, emissions benefit, fuel savings, operational cost savings, driver comfort, etc. So as we think of these technologies, we don't just say, let me go take a vehicle and make it electric. We always approach it from overall ground up design as think about what the benefits are here. So this is an example of some details behind the USPS truck it's a ground up design looking at more visibility as the mail carriers are delivering mail. This has all of the safety features like the rear corner radar, ultrasonic sensors, automatic emergency braking, pedestrian detection, 360 camera, all the benefits that you see from a safety perspective. And it's optimized to be overall designs optimized to be as efficient as possible in terms of energy consumption. And then of course it is a fully electric vehicle with the system designed for a daily mission. So my message here is that you just don't throw a technology on a vehicle. You have to think through what the customer value is. Same example of you will see these running around. It's going to start. We are beginning to deliver these. You will see more vehicles it's a fully electric refuse collection vehicle. It's a purpose-built design with the better ergonomics for people to get in and out of. All day capable in terms of the range that the vehicle provides, electronic stability control, driver distraction monitoring, blind spot detection, 360 camera, and also the connected vehicle, right? All the vehicles are connected, so with an IoT. So there is fleet management is possible, optimizing the routes, applying AI technology. So a lot is done. And again, this is multiple technologies, but all of them go towards in some way contributing to renewables, not just the electrification. Here's an interesting example of an addition of AI applied where as the vehicle is driving by, the vehicle automatically detects that there is a garbage container on the side. So it actually stops. It actually alerts the driver to stop in front of it, identifies and locates where the garbage bin is, automatically deploys the arm and grabs it and unloads it. And while it's unloading, it actually looks to make sure that what's in the garbage is fairly safe. So there is a lot of technology opportunities. All of these go in many ways towards contributing to renewable energy as well as overall sustainability. I also sit on the board of a public company that is in solar energy. So as and when the energy density, energy storage equation gets better and the solar panel costs come down, there's a lot more opportunities to integrate. All these vehicles have something called regenerative braking. Anytime the vehicle brakes, it charges the battery back. So the same kind of concept can be applied with integrating solar into the vehicles as and when the technology becomes much more affordable and much more practical. So all I want to say is that when you think of renewables, renewables have multiple dimensions to it. It isn't just all the stationary power. It isn't just one technology that applies to one thing. You really, again, scalability becomes really critical. And the scalability matters when the technology is actually addressing a customer pain point and it's cost competitive. So as coming from the industry as a CTO, part of my role is to make sure that I keep close tabs on innovators and technology people that actually do develop core fundamental technology. Always think of ways to apply it and apply it in a very practical, pragmatic way that is more scalable, and that is something that we can actually obviously make it more of a business. So with that, I am going to stop and maybe take any questions or anything others have.
Yes, Jay, thank you so much. That's a lot of that stuff is very near and dear to my heart as well, customer-centered design, especially automotive industry. So thank you so much. I think the first question that we can start with that's for both of you is, what is one project that you've worked on that has been really impactful for you?
I work on a number of different projects. I mean, the humpback whale has been something that I've worked on for since really the early 90s, and that I can see different uses of it, and people have been trying to use it in different ways on helicopter rotor blades, on airplanes, on ship propellers, surfboard fins, all these things. So the idea that we can utilize the humpback whale morphology, its design, and has an impact on all of these different aspects of technology has been really important.
Yeah, I mean, I think for me, I don't know if I can name one thing, one project that says it's, I mean, things that we do, things that we've done in my entire career has been, I would say transformative in nature in everything. You know, I know I just showed a picture of a postal vehicle, but that if you just think of the use of that and what it means to the end market, what it means to touching every neighborhood, every household, every day, 6 days a week, you know, delivering mail and packages and being sustainable, and a lot of opportunities for additional technology add-ons to it. I mean, it's very humbling, and it's very, you know, very rewarding in so many ways. I can talk about the same way about every one of my projects, right? In so many ways, it is extremely gratifying to be an engineer, because you do get to make such a big impact on people's lives.
Yes, totally agree. And that, I think both of you guys also touched on one of the questions that we had gotten in chat, which is the best part about being an engineer, which I think we've kind of talked about a lot here, is just that finding inspiration from potentially odd places, being able to take that and scale it. So you guys have answered that a little bit.
Can I add on to that though, Kelsey?
Yeah, of course.
Engineers are problem solvers. So if you don't have love for problem solving, don't become an engineer, right? The engineering is all about problem solving. I would say that, you know, all of the advancements in the world, you know, my son is a doctor, all of the advancements in the world, even the medical, he's a surgeon, even the medical profession, all the advancements in surgery, diagnostics, measurements, everything else is engineering centric. Better sensors, better way to separate, you know, glucose from something else. And there's so much engineering in any field you think of. So it's almost like the world doesn't move forward without engineering. I hope that is a way, you know, those of you high school students listening to this, you know, if there's take that away. Think about, it's not about one chemistry, you know, one this thing. It's all about the problem solving. And how do you apply multiple technical skills to solve a problem, whether it's mathematics or physics or, you know, mechanical engineering or electrical engineering, software, whatever it is it takes to solve a problem. I think to me, that's the exciting part.
It's just fun.
Well said.
Solving problems, to working with a team, to see your ideas sort of blossom and come to fruition. I mean, all of that is just sort of fun, and and the constant learning. It just makes it enjoyable.
Yes, totally agree with both of you. Thank you both for those insights there. I think with that, we're going to wrap up the Q&A session of this. Monica, I don't know if you wanted to take it to the next steps.
Yeah, well, I want to say thank you to Dr. Frank Fish and to Jay Eigner and Kelsey Farr for leading the entire day today. Amazing job. But again, I have to say the stars today are always our students and our teachers. They make this day happen. They make it an amazing and inspiring day for us all to see the work that you guys do in our classrooms. And I want to say thank you to our ET staff who were in some of those classrooms live today, which is amazing. And our ET staff who's here live on Zoom assisting with all of the back end stuff that's happening. I see one of my staff members have put in our exit tickets in the chat. Teachers and students, you have a little bit of homework left. We want to hear how the day went for you all. Please make sure you are completing your exit tickets. Again, thank you. We have our next event next week for our genetics lab, and I hope that Maybe we'll see some of you there as well. Please keep an eye out for our email with the recording along with our next events for the remaining year. And we will see you all. Thank you all for a fantastic day.